Okay, so in this video we're going to look at solving some more complicated trigonometric equations, and this question is 4 cos squared x minus 5 sin x minus 5 equals 0. And we want to solve this in the interval x is greater than 0 but less than 360. So we're going to need to use our trigonometric identities to get this all in terms of sine or all in terms of cos. So you should remember your identity sine squared x plus cos squared x is equal to 1. And rearranging this identity, we get that cos squared x is equal to 1 minus sine squared x. So let's substitute this into our equation in the space of cos squared x. We can say we've got 4 times 1 minus sine squared x minus 5 sine x minus 5 equals 0. And if we expand out this bracket, we get 4 minus 4 sine squared x minus 5 sine x minus 5 equals 0. And we can rewrite this as minus 4 sine squared x minus 5 sine x. Let's just tidy that up. So that was minus 4 sine squared x minus 5 sine x. And we've got 4 plus minus 5, so that is minus 1 is equal to 0. So we've got a lot of negative signs on this left-hand side of the equation. So if we multiply both sides by negative 1, we get something slightly nicer. 4 sine squared x plus 5 sine x plus 1 equals 0. And you should be able to spot that that's a quadratic equation in sine x. So let's use a substitution. Let y equal sine x. So now this equation becomes 4y squared plus 5y plus 1 is equal to 0. So now we can factorize this using the AC method. AC is equal to 4. AC is equal to 4, and the factors of 4 that add to give us 5 are plus 4 and plus 1. So we can write this as 4y squared plus 4y plus y plus 1. And factorizing these two terms and these two terms independently, we get 4y we can take out as a factor there. So 4y into y plus 1, and we've got a common factor there of 1 plus 1, y plus 1 equals 0. So this factorizes to 4y plus 1, y plus 1 equals 0. Okay, so now we can substitute back in sine x equals y, and we get 4 sine x plus 1 sine x plus 1 equals 0. So therefore sine x equals negative a quarter, or sine x equals negative 1. So now we've got two mini trig equations, and we need to solve these in the range x equals x is between 0 and 360. So if we just draw the graph of y equals sine x between 0 and 360, we want to find where x is equal to negative 1 quarter, or where x is equal to negative 1. So our principal solution when sine x is equal to negative 1 is x equals 270 degrees. We can see from the graph there's only one solution there. And we've got two solutions when sine x equals negative a quarter. If you use your calculator and do the inverse sine of negative a quarter, so just pop that in your calculator, you get negative 14.47 degrees. That's not in our range. That's actually when the sign is negative. This is this value here. So to get a solution in the range, we're going to need to use the period of the sine graph. We know that the sine repeats itself every 360 degrees. So if we add 360 onto this, we get this solution here, which is 345.52. And we can use the symmetry of the graph to find our other solution. So this length here is 360 minus 345.52, which is about 14.47. And if we add that on to 180, we'll get our second solution. So if we add that on, we get 194.48. Therefore, our full solutions in the range are x equals 194.48, and our second solution is x equals 270 degrees. Our final solution is 345.52 degrees.